Okay, in this part, we are going to discuss more example, okay, for integration that involve trigo function and also exponent function. Okay, so let's start with the first example. Let's say I want to integrate 50x cos 5x squared plus 1 dx. Okay, so as you can see here, you have a trigo function here. Okay, I have a trigo function, okay, which the function here, okay, I have 5x squared plus 1. It's not just cos x only, but cos of a function. Okay, so again, you can apply a substitution rule for this one. Okay, first of all, you can double check if, let's say, you let this one to be the u. Okay, and again, if you roughly try to differentiate this one, you check whether you can cut or not with the first function that you have over here. If you can cut, you can use by substitution. Again, if you cannot simplify and cancel the x value over here, if you cannot cancel, you need to use other method, which is by using IDP. Okay, so let's roughly differentiate this one to check. Okay, so if you differentiate this one, the function inside the trigo here, you will get 10x. 10x plus 0, which is 10x only, and you see here you can cut the function, right? Okay, 10x and 50x you can cut to be 5. Okay, so you remove the x variable in here, so therefore here, okay, if you have something like this, you can apply integration by substitution. Okay, if you can remove all the variable that you have in front here. Okay, so let's proceed to do the step. Again, we are using this 6 step over here, which I already discussed in part 1. Okay, so I will still using the same step, okay, in this example also. So let's start with the first step. Okay, again, first step we choose the u. So if you have a trigo, okay, this one, okay, as already mentioned, okay, we already differentiate this one. So you identify that if you use this one to be the u, you can cut with the value in front here. So, okay, let u to be 5x squared plus 1. Okay, and then we proceed to the second step, which is we differentiate the u. So again, just now we already differentiate, we get 10x, and don't forget to write dx. Okay, 10x dx. So third step, you rewrite, okay, so that the dx should be the title, so which is at one side. So the other value you bring to the other side, so you get du over 10x. Okay, next step, okay, you substitute the u inside here, okay, because this one is your u, right? And also dx, you substitute with this value. Okay, remove dx, substitute this one inside here. Okay, so you will get integrate 50x cos u. Okay, this one become u already, and du over 10x. Okay, now simplify. Again, I can cut and cut this. Okay, I will get 5. So I will get 5 cos u du. So my variable now is only one variable, so I can proceed to integrate this one. This one is just a constant here, so it will not affect your answer. Okay, just simply substitute 5 here. So integrate cos, you will get sine. Okay, so cos u, after integration, you will get sine u. And don't forget to write plus c. Okay, so the last step, okay, again, this one after you simplify, right? You step number 4, you substitute. Step number 5, you simplify here. And then you integrate. So step number 6, you substitute back the original value of u. So therefore, the last answer is equals to 5 sine 5x squared plus 1 plus c. Done. Okay, so that's the first example. So let's try to discuss the second example. Alright, so for the next example, okay, let's say if I have to integrate cos x divided by square root 1 plus sine x dx. Okay, so again, I have a trigo function inside here. So first of all, what you can do, okay, if you have any square root here, you change it to become power. Okay, make it into like one function. So I have cos x. Okay, I bring this one to the numerator. So I will have 1 plus sine x to the power of negative 1 over 2. Okay, I change to power, I get 1 over 2. So I change the position from denominator to numerator. So I need to multiply with negative to the power. Okay, so again, this one you can see here. Okay, you combine between trigo and also in the first properties, okay, which is we already discussed in the first part, when you have a function inside the bracket with a power. Okay, so you can use substitution rule. Again, inside the bracket here should be the u. So we start with the steps. So first step, we let u to be 1 plus sine x. Again, why I choose this one to be the u, because it's inside the bracket with the power. Okay, which you cannot do anything here, you cannot like expand. Okay, so this one we want to simplify it to be the u. So next step, differentiate. Okay, differentiate, not integrate. This one differentiate. Differentiate 1. Okay, this is a constant. Differentiate a constant, you get 0. Okay, differentiate sine, you should get positive cos. Okay, you will get positive cos, so you will get cos x dx. So next step, you write dx as a title, so you will get dx equals to du over cos x. Okay, so again, you need to substitute the u. Okay, this one will become u. And dx, okay, dx you need to substitute with a new value, which is this one. Okay, so substitute these two values. Again, this one will become u. This one will become du over cos x. Okay, which you already get in third step. So step number 4, okay, you substitute the integral. So you will get cos x. Okay, see, cos x, u to the power of negative half. Okay, so dx now become du over cos x. Okay, so again you can see that you can simplify. Okay, this one and this one is the same, so you can cut, you will get 1. Okay, therefore you simplify and you just need to integrate u to the power of negative half du. Okay, so use the properties. Use the properties to integrate. So this one, negative half. Okay, you need to plus 1. Okay, negative half plus 1, you get 1 over 2. Okay, you get 1 over 2. Okay, divide by the power. And don't forget to plus with c. Therefore, the last answer, substitute back the u value and change this one. Okay, instead of you have a divide of half here, you change to multiplication. So when you change to multiplication, this one will become 2 over 1, which is just 2. So it's 2 multiply with u, which is 1 over sine x to the power of half. Or you can change this one to be the square root. Okay, so you can rewrite as 2 square root of 1 plus sine x plus c also. Okay, so this is the answer for the second example. Okay, so let's proceed to the third example. For the third example, I will use exponent, okay, exponent function. So let's say if I have to integrate 3e to the power of negative 2x dx. Okay, so you can see here, my exponent here, I have a function, exponent with a function. So I cannot like use the normal integration. Normal integration only apply if you have e to the power of x only. Okay, the power of your variable is only like power 1 without any number in front here. So this one I will get like ex plus c. Okay. Okay, but this one again, if you have like a number attached to the x, okay, this will become a function. So you need to use substitution rule. So the power of your exponent will be the u. Okay, so let's start. Okay, let u to be e to x. Therefore, differentiate. So you will get negative 2 dx. So third step, dx equals to, okay, bring it to the one side here. So du over negative 2. Okay, or you can write negative 1 over 2 du. Okay, you can rewrite this to be negative 1 over 2 du. Okay, separate the fraction. Okay, then next step again, I substitute u inside here. So this one will become u, and dx here I substitute as this value. So I will get, okay, step number 4, integrate 3e to the power of u, multiply with negative 1 over 2 du. Okay, so this one I just simplify. Okay, this is just a number here. I bring it and combine with 3. Okay, so I will just bring it in front because this is just like a constant attached to the function. So you can bring in front negative 3 over 2, and then you integrate eu du. So now you can see here, okay, my exponent, I have the power to the function only with power of 1, and I don't have like any number in front here, which is I get like this. So I can apply these properties. Okay, I just changed my variable from x to be the u, so I get the same. Okay, eu du, I will get eu plus c. Okay, so I will get eu plus c. Therefore my answer is negative 3 over 2 e to power of u plus with c. So last answer, again last step, I just substitute back the original value of u. Therefore my answer is negative 3 over 2 e to the power of negative 2x, okay, exponent power of negative 2x plus with c. Okay, that's it. Right, so let's do one more last exercise, which is I will combine the exponent and also trigo function. So for the next example, let's say if I want to integrate 2 exponent to the power of tangent x, okay, e exponent of tangent x times with secant squared x dx. Okay, so I have exponent and also trigo function inside here. Okay, exponent and trigo. So this one also I can use a substitution rule. Okay, the power of my exponent here, I have tangent x. So if you apply the properties of exponent, the power of the exponent will be the u. Okay, and if you differentiate the u, if you can cut with this value, then you can use substitution rule. So if you refer to the differentiation formula for the trigo, you differentiate tangent, you will get secant squared x. Therefore, I can cut with this one letter. Okay, so I can use substitution. So proceed with the substitution rule. Therefore, my first step, let u to be, okay, the tangent x. Okay, therefore, the next step again, we differentiate the u with respect to x. So differentiate tangent x, you will get secant squared x dx. Okay, and third step, we rewrite dx to be the title. So you have du over secant squared x. Alright, and then in step number 4, we substitute back in the integral. So u is the tangent x, so later you will have e to the power of u. Okay, and also dx here, you substitute with this value. Alright, so you will have to integrate 2 e to the power of u secant squared x times with, again, this one, substitute with this value. So you will have du over secant squared x. Okay, next step, simplify. Okay, you can see you have same value here. I can cut this 2 value. So I will get 1. Okay, so 1 times 2, I just get 2 here. Therefore, I just need to integrate 2eu du. Okay, so again, integrate eu du, I will get eu plus c. Okay, so my answer will be 2eu plus with c. Okay, again, I use these properties. I will get ex plus c. So I just substitute instead of I'm having x variable, this one I have u variable, so I will just get the same. Okay, 2 here is just a constant attached to the value, so it will not change anything. Okay, so last answer, I just substitute back, therefore the answer is 2e to the power of tangent x plus with c. Done. Okay, so that's it for the second part. So we will proceed to the next part for the line, line, and also for the definite integral, which is you have the number in the integration here. Okay.